I'm Nolan Beilstein, and welcome to another episode of Gen Z in Manufacturing, a podcast where I interview young people about their journeys in manufacturing, how they intend to influence the industry, and what they are looking for from an employer. For this episode, I welcome Adam Zaouague, a 21-year-old automation and data specialist for Reata Engineering and Machine Works, an industrial machinery manufacturer for various sectors such as aerospace, medical, semiconductor, and capital equipment. Zaouague originally got into CNC as he pursued aerospace engineering. He joined Reata as a machinist and transitioned into an engineering and software role. His recent duties include managing engineering and programming and overseeing quality. He has also spent time around AI companies and experimented how to apply these tools in a manufacturing environment. Before we hear from Zaouague, please make sure to like and share this episode of Gen Z in Manufacturing. To view previous episodes, visit manufacturing.net. If you are a member of Gen Z and would like to discuss your experience in the manufacturing industry, please get in touch with me, Nolan Beilstein, at nolan@ien.com. All right, Adam. Well, thank you for joining this episode of Gen Z in Manufacturing. I like to start these off by getting to know a little bit of your background, and I wanted to ask how you discovered Reata.
When I went into college, I started at Reata Engineering as a machinist, and then kind of grew into the engineering department. We started automating a lot of things, and that's a lot of what I started working on. And then from there, started kind of managing the department as well as kind of our programming department as well. And now we're doing a lot of really, really cool stuff with software and stuff like that now.
You mentioned in our pre-email exchange that you transitioned from machining to engineering. How did your hands-on experience change how you approach engineering and software?
Yeah, when you're on when you're dealing with the day-to-day and the kind of issues of the day-to-day, engineering's number one job is to solve problems. When you deal with those problems, day-to-day, you kind of get an intrinsic look at, not what the best practices are, but more of what the true issue is. It's really hard for people to explain a problem they're having, unless you've went and dealt with it yourself. So a lot of what we do in engineering now is we go in and actually work the process for a period and actually try and live the experience a little bit. So we kind of get a deep connection to the problem. And that's kind of what I got a little bit of a taste of before. And that's what led me into wanting to move into engineering because, those were like deep rooted issues for me. And I was like, I really want to fix those. So
at what point did you realize you weren't solving machining or engineering problems and you started recognizing system level problems like you were telling me about?
Manufacturing in a company like ours is pretty difficult because we're a high mix, low volume shop. So we do a lot of different part numbers. I think it's something like 1,100 part numbers a year, all different quantities. So we're doing a lot of volume, but it's pretty high mix. So with that, you really have to look at it from kind of the 30,000 foot view. If you're trying to just micro optimize everything, you're going to have sort of a quick win for a little bit, but it'll kind of just go back into chaos. So you really have to build something that's sort of persistent across, no matter who's doing the job, no matter where you're doing the job. Really, those systems and processes kind of solidify like a solution that you've made rather than kind of just micro optimizing it in just kind of one location, if that makes sense.
You told me that the real problems in manufacturing weren't within any one function, but the gaps between them. What does that look like day to day?
How I look at it is the act of defining what you want to make should be as easy as making it. If you can define a spec or, this is the thing that I want to make and this is what I need, to make it, I define the drawing and I say, okay, this is what's important to me. And you define your intent and you define, okay, I need, this anodized or whatever it is. Defining that should just be as easy as making it. Manufacturing something should feel kind of like one unanimous kind of process or flow or act of doing rather than kind of separate, this department has this function, this department has this function. That's where ambiguity is created and where the intent, where the customer defined what they really wanted is lost down in the process. And the current standards that exist, ISO, AS, um, all those different standards, try and solve that problem in a way, but they do it um, in a really sort of I hate to say like a bureaucratic way, but it creates a lot of extra steps. So the really hard part is finding out, how do you stay compliant to the standard and do everything, right? Because the standards exist for a really good reason, but how do you do it um, in a way that feels like one continuous movement across the company? And we kind of employed, a lot of technology to kind of solve that and a lot of forward thinking.
What is an example of where the disconnects you're talking about caused a real problem?
Yeah, so I mean, so what's super interesting is, you know, uh, you have like GD&T, geometric dimensioning tolerancing, and that's a way on you know, on a engineering drawing to sort of define your intent of, hey, this is what is important for me on this component. And you can obviously measure to that intent, but really understanding the use case of the product really allows you to sort of take extra care and time and intent into either programming a part to run on something like a CNC machine, or when you're going into finishing the part, painting or plating it, you kind of make decisions that better suit the use case. Um, that's really hard to do, but um, we've really employed some really interesting technology that's kind of been able to extract, hey, this part and the name of the part, and oh, I think I know what this is used for. And when we're taking machining strategies and creating a program, you can actually, it's really interesting to see, but you can machine in a way that actually follows the intent of what the product's for.
Where do you see the biggest breakdowns? Is it between engineering and production, production to quality, somewhere else?
Um, I think it's engineering and I think it's the quality engineering and kind of production loop. But really, where it ends up happening is between the customer and the manufacturer. And a really interesting situation was, the production buyers were extremely, um, focused on a specific date that they had in their ERP or MRP system. And I went and talked to the engineers as well, and I was like, hey, these are due next week. And we're running a little bit behind schedule on these because of, we're trying to solve a technical problem with them and we're working back and forth. And I was like, how important is it for us to get these? Because we might not, but we want to put extra resources to try and get these on time. And they said, oh, well, we're actually quoting the rest of the assembly with you guys already. We actually won't need those for like another month, 2 months. So a lot of the disconnect happens, kind of in the minutia of the day to day, where they're not actually where even us or customers don't fully get the idea of what we're actually trying to do here. But when issues come up, we start standardizing a lot of things. We create standards and we create processes and we create kind of industry norms. Um, in manufacturing historically has kind of been an industry that's kind of stuck to the norm of what it has defined over time. And when you kind of stick to that and you kind of create a thing I always look at is semantics, what we call things. Um, Manufacturing and lean and all these sorts of things have the most acronyms of any other industry. And when I sit down in meetings and I bring up acronyms, and it's to other people in other departments who don't care for those, like what are we actually doing here? Um, that over time has created sort of kind of like a stagnant kind of like sheetrock of history that's really hard to move. And the older and older it gets over time, like sheetrock or bedrock, it kind of just solidifies and won't change. So that's why I find it really, really fun. We have a really young engineering department, and there's a lot of people kind of in my generation who, love to ask the like why questions and say, you know, um, with the sort of technology we have now, it's like, well, why do we do it this way? And if you can challenge that, but you can actually bring some actual results, then you can really start kind of making some headway.
How has Reata encouraged young people who work there to ask those why questions?
Yeah, I mean, well, I mean, I started my life there kind of asking the why questions, and um, when you ask a why question, we give you the ability now to, do a presentation, have a meeting, kind of make your case. And we have sort of precedent for that actually leading to something real. We've bought machines, we've bought equipment, we've invested in software. We've done a lot of things that have actually led to saying, hey, if you have an idea and it's good enough, we'll 100% invest in making that happen.
Do you think talent gap or coordination is a bigger problem?
The talent gap is a problem mostly on the skilled workforce side. People aren't as interested in like your traditional machinist job as they used to. Only reason I pause there is because coordination is a huge issue as well. But really, it's the interest is kind of dying for industries like ours, and I don't really see it coming back. You know, um, but what ends up happening, and I don't think this is as big of an issue, is um, people in my generation aren't as kind of interested in the machining kind of side of things. Um, but they're lot more interested in sort of the tech and that sort of side of it. So what ends up happening, and what I see happening in the industry is that interest will lead to I think machining and manufacturing is going to look way different in 10 years than it used to, because we're going to invest so much in the technology side that some of the things that you thought need a skilled workforce will actually kind of be um, kind of just changed in how it's done. And then that leads to kind of fixing the coordination problem.
Yeah, let's talk about the technology aspect a little bit. You told me that AI can have a real world impact in manufacturing. What does that look like in practice?
Yeah, I mean, we're working on I can't speak too much to what we're doing, but working on some really interesting things where, I don't think, you know, programming a CNC machine is going to look the same in 5 years or even in the next 1 to 2 years. I think it's going to look very, very different. Um, I think running a CNC machine is going to look a lot different. I think automating lines is going to look a lot different. Um, I always hate to be on the AI hype train, but some of the tools and stuff that we've built using agents with sort of agentic workflows, it's pretty remarkable about the things that you're able to do. Um, when you give sort of, these AI models reasoning and you give them chain of thought and you give them sort of self-healing workflows where they can kind of reason and try things and verify things and then redo what they just did, you get results that are actually, pretty remarkable and don't require sort of I hate to say like human input, but sort of like any changes after it's been done. And once you get there, and once the quality of the outputs goes up, um, you sort of end up with some really really cool use cases.
Like what? Do you have any examples you could share?
We built an agentic platform where pretty much anything that you can do in your ERP or on a computer, we can automate. Um, we built a platform because we wanted to give the people on our team the ability to kind of create their own workflows. They see, hey, this is sort of an issue I'm dealing with, um, something I have to do quite constantly. How can I add an AI agent in there? What's really cool is these AI agents are sort of like team members. You're able to email them. We worked with a startup in San Francisco who's making sort of an email inbox for AI agents. And you're able to email them, you're able to Teams them. So they kind of act like kind of coworkers. They'll ask you questions and stuff. It's pretty cool. And that sort of helps that sort of like one motion of manufacturing sort of idea because they're able to kind of keep the context over time. And you just get to focus on making things and making things better instead of sort of, what spec was this and oh, I got to order this material with this spec and stuff like that. It's kind of all done for you.
Where do you think companies get it wrong when they're trying to apply AI on shop floors?
I think thinking too small. Um, the whole like cybersecurity CMMC sort of deal has sort of in this industry is sort of stagnated growth in technology. Um, and you sort of had to have to think outside the box. You can make something extremely secure from a cybersecurity standpoint, while not, sort of limiting your growth. But I think it's not thinking small, but not thinking that the sky's the limit. It really is, especially nowadays. The industry is just moving too quick to not try and do some of these things. But it's really just starting, seeing where you can go, and then sort of moving from there.
If a company wants to modernize its operations, where do you think it should start? Is it a emphasis on technology, people, the process? What do you think?
I think it starts with people. I think if you find people who are willing to learn the technology and understand it, the gap to understanding some of the stuff and building some of the stuff is like dramatically shrinked over time. So now what matters a lot more is like what you build and the ideas you have and sort of the direction you want to go. So what's really interesting is a lot of these shops have really, really good ideas on things they want to solve and fix. I mean, I talked to a lot of guys and they say, "Oh, well, I wish our ERP could do this or this or this," and sort of just realizing, okay, if I can find someone, it doesn't have to be a software engineer or anything like that, but someone who can kind of learn and apply some of those things, um, that could, get them started right away.
How do you think manufacturers can better capitalize on this new wave of tech savvy talent? A lot of young people that have been growing up with it and they're ready to go.
The hard part in manufacturing is it's so based on the now. What's the problem now? What's going on now? And a lot of times to make really good impact, you sort of need to step back and kind of uncover the blinds and kind of take your blinders off and sort of look at it from like a holistic standpoint rather than saying, okay, this is the problem today. I'm going to just try and solve that. Instead, it's like, well, how can I make something that solves a problem that's similar to this every time?
Where is the bigger chance for young people to impact manufacturing? Is it on the production or software side?
I think it can be on both. I've seen people who've had like really cool ideas for just, doing the machining side of everything, and coming up with that. And then I think if people kind of do really cool things on the software side to kind of help the guys on the other side, but the other guys really understand what we're trying to do on the software side because they're, they kind of understand technology. I think that together can kind of make some really, really cool change happen.
And you teased it a little bit before, but what do you think the connected manufacturing industry is going to look like in 5 to 10 years?
Yeah, I think if our customers or anyone really has an idea of something they want to make, you know, the making part really shouldn't be the problem. And that intent of what they wanted to make and how they want it to work needs to kind of flow down in kind of one continuous connected way. And I really do think, yeah, like the act of defining what you want to make will be the pretty much the act of making it. And that's sort of how it should and will work in the future.
Thank you for watching this episode of Gen Z in Manufacturing. Please make sure to like and share the episode. To view previous episodes, visit manufacturing.net. If you are a member of Gen Z and would like to discuss your experience in the manufacturing industry, please get in touch with me, Nolan Beilstein, at nolan@ien.com.